Hey there, Foppers, and welcome back to our quest to finish every single video game. Absolutely all of them. Today, we're back with more The Farmer Was Replaced. And last episode, we did mess around with the treasure, trying to get that to work, and we couldn't get it working. I've been tinkering a little bit with how to do it in between episodes, with basically no luck. I did purchase lists in Upgrade 3. We had what we needed for that, and I thought that would help us out a bit. And I have a good idea right now. I think I know how to do it. So let's see if we can get this working here. So first we're gonna define a new list, and this will be, let's see, uh, dead ends is equal to, and then we'll just define a blank list like so. So currently it starts out empty. What we want to do is for the farmer, when he's standing on a dead end like he is right now, he's going to add that to the list and then move out of the dead end. So that will be one to the north here. And then he's going to see the dead end as kind of a new wall, meaning he can never go down. And then it will just go a random direction. So say he goes up here and up here. Oops, dead end. He goes back here, wall here. And now he's suddenly standing in another dead end. So he goes down, a wall there. He keeps going over here, dead end. And then he keeps creating dead ends all the way back down here. And he basically does that until the entire map is dead ends or he finds the treasure, which he will eventually if we do that. And I think I have an idea of how to do that, so we're gonna try getting that done. So first here, we're going to want him to move just. Well, let's see how many entrances there are. So can we use move? Let's see, move. I did learn that you can do this. Uh, does north, east, south, and west? Does that equate to? Let's see. I wonder if that equates to like numbers, maybe. So move, then say one. Does that work? No, that's not valid, unfortunately. What about if we take x, y? No, it takes one argument, so we do have to use the things. That's fine. We can do that. Can do that. So let's see. Uh, can we return? How did the move return in an if or yeah, in an if? Uh, it does not say there. Where does that say? Uh, maybe it's Mises actually. Yeah, it returns true if it succeeded and false otherwise. So we can try moving if we cannot see before we move. That's a shame. Uh, I guess what we can do is at the start of a run here, or like before he starts moving, we try moving him north, and then if it succeeds, we add one to a counter. So we want to define the counter here, I think. So let's see. Let's take possible moves. It's equal to, and it starts at 0. And then when we start a run here, we do possible moves. We set that to 0 because we want to check for this go through. Okay. So we have that at 0 here. Then we want to try to move north. We can actually use this move here. Move north. And then afterwards we do if move north. So if he did move, we add possible moves plus equals 1. And then move south. And we know it's going to succeed in moving south because it succeeded in moving north, right? And then we do the same thing for all directions. We want to copy this 3 times. 1, 2, 3. Like so. This is definitely wrong though. I want this to be here. This to be here. Like so. And I want to do the same to east. And this will move him east instead, and then west again. And then we want to do the same to south. And check if he moved south. And if it did, he will move north. See, north like so. Then we'll check west. And then if it did move west, we add 1 to the counter. And we move back east. This is looking right for now. And then, if possible, moves is equal to exactly 1, then we do something. We add this position as a dead end. We don't need to check for 0, because if it's 0, he has to be standing on the treasure, or the code is broken. So we don't really need to care about that for now. That's fine. Then we do dead ends. And what you can do with lists is you can use an append function. So we append, and then I think we append like so. So we do get position X and get position Y. So we add that to the list. And also we wanna add in the behavior so that the dead ends actually count as walls. So for this whole check, we don't want him to move to a dead end if we know it's a dead end, you know. So we actually want to add that little something here. So, and let's see, we do get pos X. We can do list contains, I think. So let's see. Can we not do list contains? That's a bummer. Well, I guess we do. I guess we do. Oh, how do we do that? That's an issue. Guess we can contain all of this in a check. So for I in length of terms, we want to check all of the numbers in dead ends, and then if north is ever in dead end, then we say can move north false. Let's see. If I is equal to we want to do length, and then we want to check the I index actually. So this is actually it's I'm sorry, I'm messing up here. Dead ends I. So this is the index in dead ends. So if it's say 0, which it will start with if we have length of 1, he will check the first one. And if that is equal to get position X like so, then get position Y like so. And we're not quite done yet because we want to check for north. So that's y plus 1, right? That's 1 above us. Then we can say can move north is equal to false. So we want to have a bunch of these. We want one for each direction. So can move north, and it starts out true. And then we do the same 3 more times. Yeah. We just change them out so it's east, then south, and then west. And we want to copy all of this. And at the start here with the possible moves, we want to set all of them to true again. Just in case they were set to false in the previous run, but we're now standing on new squares, we want to do the check from the start. Uh, you can just copy. We can just use one for loop, and we can check all of them in the for loop. Let's see. This is messing up the indentation. That sucks. Like so, and like so. I want to do east, south here, south, and lastly, I want to do west, like so. I want to change all these. So east, that's x plus 1, not y plus 1. South is y minus 1. And then west is obviously x minus 1, like so. So now, before we even attempt moving here, we do want to add an if statement. So if can move north, and I guess this is kind of misleading because we don't actually know if it can move north. We just know if the dead ends make it so it can or can't move. Can move east, like so. Then we try moving east, and he may not be able to. Can move east doesn't actually mean he's able to exactly. It just means that the dead ends doesn't say it's impossible. South there, and then finally we do the same for west. West, like so. So yeah, if he can move there as a dead end, then they will not register as a possible move, allowing him to count, say, this square as a dead end if he's already been to this square. Yeah. So now if possible moves is equal to 1, then he will add this position to the dead end. And then after that, we can try just moving. Direction doesn't really matter which one we start with. So if can move north, then move north. And then we check. Let's see, how do we do this actually? Uh, I guess we try that first. Then we do if, and then we check if we actually move north, because we can do this, move north. So if it did not move north, uh, and also, and he can move east according to the deadlines, then I will try moving east, like so. Now we do have an issue, because how do we check for a multiple? multiple of these. So if it didn't move north, then it will try moving east. And then we can add another one, but if it did move north, that wouldn't work actually. I guess we can just check. uh, if not move north. I have no idea if this works. And not move east. And also can move south. Then it will try moving south. And then lastly we do the same thing, but we check for south as well. I think that could work. And not move south. Also, as I was checking for south there, we want to do west. Then I will move west. I think this might work. I do not know though. Let's try it out and see what happens now. Okay. How did the moves work here again? Move returns true if it succeeded or false if it didn't. So we actually remove this. We don't need to check for the direction in the if. And I guess that simplifies it a bit, because then we can just have one move here. Because if we failed at the last move, then they will try to move. That makes sense. So it's like so, I think. Like so. This is not a valid expression. Why isn't it? Can we just do not move? Is that valid? It seems like it is. I guess. Can we try running this now? That works. Form a sequence right over. So I guess because this is 0, so if length distance is greater than or equal to 1, then we can try this, maybe. And if it isn't, then we just skip it entirely. Okay. Gets up here. Move takes one argument. If move. Okay, so do we need an argument or not? That makes no sense to me. I guess we add back in all these. Can we just, maybe this is simpler. Back in all of those there. I think that's looking good, yeah. And what we actually need to do then is not, that does not give a syntax error. Okay. Something like that. And then we just need to add the if back here. So if length of distance is greater than or equal to 1, Then we can do this check. If not, we don't bother doing this for check since it doesn't work. This does something. And he seems to be getting stuck. Oh man. Oh man. Why is that? And he does not move back north. He should move back north, right? Wait, why doesn't he? Why doesn't this move south? Can move south. He tries moving south and he succeeds. And then that check, it doesn't succeed. Does it check beforehand? I'm so confused. I'm so confused. I think I don't understand how the move works. If you just try, I mean, you can just do like so maybe. So maybe it just checks if it can move from the current position. That would make things easier. Okay, and then we can do if move north, and they can move north according to the deadlines. Then we can have an else if instead. Then we can have move east, and then we can have an else if here. Let's do that here too, so I don't forget. Then we can have a move south here, like so. And finally, we did a move west. Does this work now? No, because this is a dictionary. Think we can change it to like a list instead. A list in a list. I think that works. So we just need to change some of the brackets here. Wasting all of our pumpkins trying to do this, but it's fine. We can get pumpkins again. One more there. There we go. Can we do it now? No, we cannot. Why is that? Why is that? Spoon moves is not equal to 1, so it does not append. Then they cannot move north. He checks for east. That's fine. So he moves east. Then he goes back up. And possible moves plus one again. Wait, he moves when we use the if move. Oh, that changes things. Okay, so we want to add the inverse here. So move south, like so. Move west, like so. I think maybe I understand how the if move works now. We had the north there, and we have the move east. So he actually tries to move. I thought he was just checking. Okay, and then if move north and can move north. I guess we want to have and can move north in a separate here. So if move north succeeds, then we want him to just move north and not worry about anything. And then if it doesn't succeed, we want him to move east and not worry about anything. Can we do something like this? Uh, okay, that doesn't work. So the issue here is that he's actually moving, if he can. That's annoying. Let's see. We don't want him to actually do anything, so let's just flip. That was a command, I think, for doing nothing. Okay. My question now is, does he actually try to move when we have an AND function? So if it does, we have an issue. That will make things difficult. Flip has never been defined. Okay. What was that again? Do a flip. Okay. Do flip like so. Then we just copy that over, and we just do that a few times here, like so. Okay. One can be iterated in a for loop. Why not? I guess it's not a range. If we say range, maybe? Range. I guess we could skip the one check. I kind of misunderstood the error message there, I think. He does a lot of flips whenever he moves. That does take additional time, so I'd like to get rid of that. Definitely. And then it's stuck again. Oh man. Can we just get to a good point here? Okay, so he moves back, at least in this one. He does move north. Okay, so that's the issue. He does move north. Oh man. Uh, okay, I'm gonna have to end this here and I'll have to think of a solution for that. We're very close. We can definitely do it in the next episode. But yeah, anyways, thank you guys so much for watching this video. I do hope you enjoyed it, and I hope we'll see you next one. And please do remember to subscribe if you enjoyed the video. It really does help me out a lot. Also, have a nice day and goodbye.